Chapter 10.5, Independent Events. So the vocabulary for today are independent events and compound events, or a compound event. So an independent event is when two things happen, but they have nothing to do with each other. For example, if I have some marbles in a bag, let's say I have some blue marbles and I have some pink marbles. So let's say I draw out a blue marble and then I put that blue marble back in the bag. What's the probability that I'm going to pull a pink marble? Well, because I start with 6 marbles, the probability of getting a blue marble is 4/6. But because I put that marble back in the bag, I still have 6 marbles when I go to draw out a pink marble. So they're considered independent events. We'll talk more about that in a minute. A compound event consists of 2 or more separate events when they are independent. Okay? So 2 or more separate events. So how do I find the probability of independent events? I'm going to multiply the probability of A happening, the first event, times the probability of B, the second event. So let's take a look at example 1. Decide whether the given events are independent and explain. So you toss a coin twice. The first toss you get heads, the second toss, or then you make a second toss. Is that second toss going to be dependent or independent? Let's say I get tails the second time. Well, I toss a coin. Okay? I toss that same coin again. Does the outcome I got the first time have anything to do with the outcome I get the second time? No, my options are still the same, heads or tails. So these are independent events, okay? Because the first outcome, getting a heads, has nothing to do with the probability of getting tails the second time. My probability of getting tails is still 1/2. So part B, you select a colored pen from a box of assorted colored pens. Then your brother selects one after you. So if you select a pen, let's say you select a nice pink pen here. It's a little bit more like a dagger, but you get the idea. Look, it's a little pen. Okay, so you select a pen from the box. Now, you keep that pen. Your brother can't pick that pink pen. It's not an option because you already have it. He's going to go ahead and pick the green just because green is his favorite color. But the probability of him choosing a green is less than it was before because he has one less color to choose from. So these are not independent. Because you kept that pink pen, he had fewer pens to choose from, so they are not independent events. So let's take a look at example 2. You have a bag containing 3 red cubes and 2 yellow cubes. I'm going to go ahead and draw that bag really fast. Okay, so here's my bag, and I have 3 red cubes, and I have 2 yellow cubes. You draw a cube from the bag and replace it. So you take one out, and you put it right back in. Then you draw a second cube. Find the probability that both cubes are red. So the probability of pulling a red cube the first time is 3/5. So the probability of getting red is 3/5. 3 of the cubes are red, and there are 5 cubes altogether. So I want to find what is the probability of getting red and then red again. Because I replace that cube, and this is the key word here, replace. Because I put that cube back in, the probability of getting red the second time is still 3/5 because there are still 5 cubes in the bag and 3 of them are still red. So the probability of getting red and then a red is 3/5 times 3/5, which equals 9/25, because you multiply fractions straight across. So the probability of getting a red and then another red is 9/25. Okay, so let's take a look at example 2, the quiz show. 3 questions are asked during a quiz show. So question 1, question 2, and question 3. Each question has choices A, B, C, or D. You guess each answer at random. What is the probability that you answer all 3 questions correctly? Well, the probability of answering any question is 1/4. Only one of these answers, A, B, C, or D, is the correct one, and there are 4 possible answers. So the probability of answering question 1 is 1/4, but the answer to number 2 has nothing to do with the answers to number 1, so the probability of answering number 2 correctly is also 1/4, and the probability of answering number 3 correctly is also 1/4. So if I want to find the probability of all 3 correct, I'm going to multiply 1/4 times 1/4 times 1/4, the probability of all 3 events, which equals 4 times 4 is 16, times 4 is 64. So I have a 1 in 64 chance of getting all 3 questions correct when I guess. Okay, that's it for examples. If you have any questions, come see me the next time you're in class, and please complete your QCs and CYUs.